Okay, I'll start by just introducing myself. So my name is Claire Metcalfe and I work on something called the STEP Support Programme. And I also work on Enrich on the post-16 problems. Ems, would you like to introduce yourself for a second?
Hi everyone. So I'm Ems Lord, I'm the Director of Enrich and I also work with Claire on the STEP Support Programme and really excited to hear about tonight's session.
Okay, brilliant. So this is going to be a first STEP teacher webinar. We've done lots of webinars for students before. This is the first one we've actually done for teachers. So I'm going to start by just introducing a little bit about what STEP is. Some of you might know this already, but if you don't, it's a useful just bit of background. So STEP stands for Sixth Term Examination Paper. So that's because it's taken in the sixth term of your sixth form studies. Pre-1986 or so, the way that Cambridge used to do entrance is that you used to sit a paper in November and you either sat it during your fourth term of sixth form or during your seventh term. So some students would stay at school for an extra year and do their Cambridge entrance after they'd done their A-levels. But in about 1986, that all got changed and we ended up with STEP. Now, there used to be STEPs in all the subjects. Those started to peter out early this century. And I think the last ones finished in about 2003, which coincided with AS grades happening and also the AEA starting to be used more widely. So from about 2003, it was only maths that remained. It's been part of Cambridge Maths Office for a very long time. There are some other subjects that will start to ask for a STEP paper now. So normally that is engineering. I think occasionally some of the computer scientists might ask them. That's very much a college dependent thing. There are lots of other universities that either say you have to have STEP or they recommend that students work on STEP. So for example, this year, Warwick have changed their admissions slightly, and they're now saying that for the majority of applicants, they need to either offer MAT, TAMUA or STEP, which of course means that if they have missed the MAT or TAMUA, because those happened last month, they will have to now sit STEP. And I think for Warwick, they want a grade 2 in STEP. This is part of a reaction to the uncertainty with A-level gradings and the huge number of students who are getting A star in further maths. So they're introducing another measure. And the last thing I just want to say is there are now 2 STEP papers. So there's a STEP 2 paper and a STEP 3 paper. Very sadly, STEP 1 was, the last sitting of STEP 1 was in 2019, and that's now been discontinued. So it's just STEP 2 and STEP 3. Perhaps at some point they might get renamed. That's not going to happen for a while because we quite like to keep things as consistent as possible. So that is a really brief introduction as to what STEP is. I want to talk a little bit, I want to share the positive side of STEP. So I think there are lots of benefits to STEP. There's lots of benefits to the students, and I'm going to talk about a few of those first, and then there are actually some benefits to the university as well. One of the main benefits is that the style of STEP can give students an insight as to what A-level math, university maths might actually look like. So I'm going to just try and swing a web browser over. So I found a couple of university exam papers. This one is from Cambridge. If you have a look at this question, it looks very much like a STEP question. This one, I think, is from Sheffield. Slightly different in style to the Cambridge one. It actually shows you how many marks there are per section, but it still looks a bit like a STEP question. And finally, I think this one is from Durham, if I remember. Yes, that was from Durham. And again, you can sort of see the similarities, how it looks a little bit like a STEP question. So that's the first benefit. It gives students an idea of what they might be letting themselves in for if they go on to do a degree in maths at university. The second benefit, which I think is a really good benefit, is it gives students the experience of being stuck. So some of the students who want to do maths at university might never really have had many questions which they didn't know how to do the question. So they might have got things wrong, lost negative signs, things like that, but they haven't met many questions where they've looked at it and just think, I'm not sure where to start. And STEP is a really good way of introducing them to problems where they should have the knowledge for which to do it, but they might not know which bits of that knowledge they need to grab first. And it's part of building the problem solving aspect of being a mathematician at this higher level. The third one, and this quote comes from a report by Ellie Darlington, which was written in 2017. She spoke to about 400 or 450 students from 27 different universities and asked them about some of the admissions tests that they'd sat before university. And I think in her results, 91% of those who had to sit STEP said that was good preparation for university. I think 66% of those who sat STEP but didn't have to said that STEP was good preparation. 50% of those who sat maths said it was good preparation, and I think it was 40% of those who sat AEA, but I can't remember that number. So out of the students, those that had sat STEP said that was the best preparation that they'd had out of all the admissions tests. And lots of these students take more than one admissions test. Some of the things that are benefits to universities, firstly, universities are comparing students from all sorts of different exam systems. So they'll have lots of international students applying, and STEP is a sort of across the board measure of how able the students are, and also how they can how they tackle these difficult problem solving questions. Saying that, STEP is very much based on A level, which I will talk about a bit more in a minute. It means for Cambridge, certainly, we don't have to make the final decisions at interview. So we might have students who perhaps we don't think have given their best at interview, but we think do have the potential. We can give them a speculative offer. We can say, okay, we think you can do it. Here's an offer, go and show us that you can do it. So Cambridge for maths, I think, has an offer ratio of about 2 to 1. So it makes lots of offers so that students can then work on STEP and then show in June that they can do those questions. And the final benefit to universities is that the colleges can have a look at the scripts. So if a student misses their STEP offer, it doesn't mean that they haven't got a place. The colleges can have a look at the scripts. They can look at whether a student made lots of really good attempts, but unfortunately missed a couple of crucial bits, or whether a student was actually flailing around and couldn't get much out at all. So the college can make a decision on the student looking at how they approach the questions. They can also, as part of that, look at the whole student portfolio. So look at the background of the students, look at how they performed an interview, put all this together and make a, I'm trying to think of the right word here, but make a final decision based on the whole portfolio of what that student is provided. Okay, I'm going to stop talking for a second. Well, I'm going to stop talking about a minute. This is an example question. This comes from Step 1, 2005. If you've looked at the STEP support program before, you might have seen this question before. What I'd like you to do is I'd like you to have a quick look at this question, and then in the chat, can you try and say what sort of maths you think you might need to use to solve this question? So what sort of topics you'll need to use? So we've got a few suggestions: algebraic fractions, quadratics, including the discriminant. Yeah, lots of people mention the discriminant. So this is somewhere where, if I'm wrong, I would love it for somebody to correct me. But I think a question of the form x over x minus 2 plus x over x minus 3 equals 1. Is that now on GCSE? It used to be last time I taught it, but it may have changed. Yeah. So there's a lot of similarity between this question and a GCSE question, or at least this first part and a GCSE question. The main difference is that instead of having the 2s and the 3s, we've got A's and B's. So you could give this first part of a question to a GCSE class and see what they come up with. And actually this part here show that if A and B are either both negative or both positive, that bit can, for a student who's never seen a STEP question before, that bit can actually be a little bit tricky to get a handle on. I'm just going to try and get rid of the annotations. The question goes on. So a lot of STEP questions, you have a first bit which is relative, which is easier, and then hopefully that should help you get to grips with the second part. The second part, we've got exactly one real solution. So if people have said they looking at the discriminant is a good idea. This STEP question is also quite steppy because if you look at your quadratic equation, it doesn't have the form. I'm just going to try and delete that. Nope. Okay. If you look at the quadratic equation that you end up with, it doesn't have the form ax squared plus bx plus c equals 0. And so a place where students often go wrong is they'll write b squared minus 4ac equals 0. And then they'll substitute some of these a's, b's and c's with the correct things, but they might not substitute some of the others. And that's where they quite often come adrift. So it's a good lesson in being careful with your algebra, and also being careful that if you are using B to represent two different things, that you don't confuse the two. So it's a really nice question, this one. And the other thing I'm going to say about this question is this is on the first foundation assignments that we have on the STEP support program. So I'll show people where to find those in a little bit. A little bit more about STEP. I've said that it is based on A-levels. Because it's based on A-levels, in 2019, the STEP specifications were rewritten, and they were to link in more closely with the A-levels. There are lists of what are called DFE prescribed content. I was going to try and write that, but for some reason I can't do that. Excuse me, I've got so many buttons everywhere. That's better. So this is based on the DFE prescribed content. And basically that's a list of what should be in A-level. Now for further maths, it's a little bit more, it's not quite as prescriptive. It only says what half the further maths content should be. But for A-level, most of it, the DFE has said, this is what everyone who's doing an A-level should cover. Apologies for people who aren't teaching the English A-level. This is all based on the English A-level. So the Scottish Nationals, the Welsh A-levels are slightly different. In the specifications, in the STEP specifications, it does indicate which bits are not in the standard A-levels for England. There were some very small changes in 2020, and there will be a very small change this year. The very small change is that I think that the formula for the exponential is going to appear twice. So the formula e to the x equals 1 plus x squared over 2 factorial is going to appear both in pure maths and in probability. So very, very, very small changes. Another reason for that is we don't want to change things whilst all sorts of other changes are going on. And there's also on the STEP support program, there is a mapping document. So because the specifications changed in 2019, the majority of STEP papers follow old specifications. So in the mapping document, we try and show you where the old papers link to the new specification. Okay, this is an example of what the specification looks like. So to try and show you what I'm talking about with the prescribed, with the extra content. So I just need to change my color again. So things like this, which are in bold, these are things which are not in the standard A-level English A-level. So all the rest should be covered in A-levels. Those bits are not. Now, these are both from what we call the Mathematics 1 specification. That was the old step 1. So that is assumed knowledge for both step 2 and step 3. There are also specifications specifically for step 2, which is mainly based on AS Further Maths, and also for step 3, which has the full A-level Further Maths in it. The other thing to remember, though, is that all of this single A-level maths is covered in step 2 and step 3. So you will get probably quite a lot of questions on step 2 and maybe some questions on step 3, which are all on single A-level maths topics. And I'm going to show you an example of that in a minute. Some of the additions in the specification are things like this and other and higher. So in A-level, you might be restricted to dividing by a linear factor. In STEP, we'd expect you to also be able to divide a polynomial by a quadratic factor. So we're trying to make it very clear what the extra bits are. Okay, I'm going to just take a moment out for a second to show you a bit more of the website. So if you haven't seen the STEP Support Programme website before, it looks like this. I'm just going to try and make this a bit bigger because it's quite small. That looks a bit bigger. And there's lots of options at the top. At some point, we probably need to rearrange these a little bit. But the thing I'm going to talk about first is specifications. So if you go to additional resources, specifications, we've got a link to the Cambridge Assessment Emissions Testing website. These are the people that run STEP. And that's where you'll be able to find the most recent STEP specification. So the one for 2022 isn't up there yet. It should be up there within the next month. So at the moment, it's the 2021 one. There'll be hardly any change, but you might want to just to refresh in December, and hopefully the 2022 one will be up there as well. When the 2022 specification goes live, I'll tweet about it on the STEP Support Programme Twitter account, so you'll know that it's there. The mapping document, which I mentioned, this indicates parts of the spec that came from the old step 1 and step 2 specification, and the parts of the spec that comes from the old step 3 specification. And that I've color coded it in blue and red, and there are some bits which are new compared to the old specifications. So that there's not a lot of surprises. All of the step 1 or mathematics 1 as it is now spec pretty much comes from the old step 1 spec. And then there are a few bits later on. When we come into mathematics 2, there's a bit of complex numbers which are now in mathematics 2. Whereas if you look at old step papers, there won't be any complex numbers in step 2. The only other thing I want to talk about in terms of specifications is we are aware there are some bits of the specification which are not covered in schools as a matter of course. So we have some notes here for students who might want to just refer to these when they're working through some step questions. So for example, if a student is wanting to sit step 2, perhaps because they have got an offer to do engineering or some other, or that they're applying to a university but don't have further maths, then they might want to have a look at this, and then they can get a bit of support on the bits of specification that they have not met. Okay, the other thing to say about specifications is it's probably best not to get too worked up about what exactly is on the specification. By working through past papers, students will get very much an idea of the sense of the style of STEP. And in some ways, that's almost more important than the actual content. Okay, I'm going to give another example now, and a very quick break for me. This is a question from last year, or from this year, step 2, 2021. What areas of maths do you think you'd need to answer this question? So if you could put something in the chat, have a think about it first, and as before, perhaps concentrate on part I. So this is probably one of my favorite sorts of step questions, in that it introduces something new. So if you've met the floor function before, you probably know what this thing means. But it doesn't matter if you don't, because it does actually explain it, and you don't need to use the term floor function. This thing is probably new to you, or probably new to the students when they sit the exam. So that's the fractional parts. So there's a few examples. So we know that x is equal to an integer part plus a fractional part. And it's got an example when x equals 4.2, then the floor part, the integer part is 4, and the fractional part is 0.2. And it's also got an example when that's negative. Have a think about this part. Can anyone look at that and tell me what floor x must be? So in the chat. Okay, we've got 3 votes for 4, which I agree with. And so what must the fractional part of y be? Okay, a couple of votes for 0.9. I think this part is slightly harder. And I would start on the floor again. So for this one, what must the floor of y have been? And the key thing here is that this thing here must be between 0 and 1, and this has to be an integer. Okay, we've got a few -2s coming in. And if that's -2, then this bit must be 0.6. And then we can stick them together. So x is this plus this, and y is -2 plus 0.9. So this is a question where I don't think you need really much maths knowledge at all in which to tackle it. So it's a step 2 question, and we say that step 2 is based on AS Further Maths, but this question doesn't need AS Further Maths, it doesn't need A-level maths. It needs a bit of thinking about. So it's a really nice, certainly this part of the question is a really nice question to share with students and to get them thinking. And afterwards you could say to them, well, that's part of a Cambridge emissions paper. Haven't you done really well? It goes on a bit. So this part gets a bit harder, but it does give you a hint. And then between these two, there's not so much a trick, but there's a lot of similarity between them. And if you just go very quickly through it, you might assume that because there's all these 2s, you just halve your y's from before. And it doesn't quite work like that. But I'll let you have a play with that question yourselves and work out what's going on with the third part. So yes, so lots of the step questions do not actually need A-level maths, but they do require you to take on new material and think about it and then apply it. Okay, let's How I'm doing for time, past, brilliant. Okay, I'm going to talk a little bit about what we've got on the STEP support programme to help your students prepare. And I'm going to show you, I'm going to do another tour around the site. We've got two main parts. So the first part are what we call the foundation modules. So we are funded by the University of Cambridge to prepare students to do sit STEP to come to Cambridge. So we're preparing students for step 2 and step 3. But a really important part of that is starting students early on in year 12. And these are also really useful for year 13 students who want to go and do maths at other universities. So those who aren't going to be sitting step 2 or step 3 in year 13, but are thinking about doing maths at university or something with a lot of maths in it, these are giving them quite a gentle introduction to problem solving skill at the sort of level that they will need when they get to university. So there are 25 foundation modules. They are on a graduated scheme. And for each one, there's an assignment which has a bit of a warm up, some maths to get you going. It has a section which practices the skills that you'll need to do the step question. It has a step question. And then there's a bit at the end, which might be some logic puzzles. Sometimes it's introduction to other types of maths. So we have an introduction to fractals on one of the assignments. We have an introduction to Diophantine equations on another. So it's focused on improving confidence with problem solving skills and also expanding a bit on what they do at school and showing them some areas of maths that they might not have met before. Step 2 and step 3 is where it gets, I don't want to say this a bit more serious, but there are more step questions. So for step 2 and step 3, we divided up the specification into topics. And then for each topics, we've selected a few step questions. We provide what we call topic notes. So one of the main problems with trying to do step is you might not have covered at school yet everything you need to do the question. And so there's just little summaries of what you need to do to attempt these questions. So students, if they're not sure, they can look that up and maybe use one of the results. So the idea there is that students have a go at the question. If they can't make much headway, then they can have a look at the hints and then hopefully use those to actually finish off the question. And the fourth document, which is really important as well, is solutions. So I would strongly recommend that even students who have actually think they've done the question completely correctly, they should still have a look at the solutions. New for a couple of years ago are worked papers. So these are step 2 and step 3 papers where we've produced full solutions. And when I say full solutions, they are very full solutions. So it's more than you might expect someone to do in an exam. There's also lots of bits of discussion about, I did it this way, but then afterwards I realized there was actually a much easier way to do it. But both ways are equally good. Both ways would have got the marks. Some other ones where I might say how I started, what I thought I could do to get me going. So they're more than just solutions. There's also a bit of discussion about the questions as well. And I'll show you where to find those in a second. I've talked about the notes on the topics which are outside the standard specs. And we also have some self-help and support. So what I'm going to do is I'm going to show you where some of those things lie. So if you go back to the home. So the step support modules, the foundation modules lie here. And there are 25 of them. There's also some collections of step 1 questions right at the end, which have some quite nice questions in them as well. And assignment 1, if we look at assignment 1, it's been a bit slow. There we go. Make it a bit bigger. You can see that assignment 1 is that step question that I talked about earlier on. So the way the step assignment is built up is it actually starts with a bit of preparation where you're practicing these algebraic fractions, you're talking about the discriminant, and then there's also a bit of an inequality at the end. But those are practicing the skills that you need to do the question. The warm-up is just meant to be a bit of maths that people have met before, but just to get them going. But some of the ideas also can crop up in other step questions. And for things like expanding this in the solutions, I talk about how I would do it, which is probably to write a table so that I make sure I don't miss anything. But so there's some suggestions as well. It's not just here's the answer, here's how you might get the answer. And then we call it a warm down. So the warm down is quite often, in this case, is a little geometry puzzle. I think in one of the step assignments, we talk about Euclid's Bridge of Donkeys, which is quite a nice geometry puzzle. So that's what a foundation assignment looks like. The step 2 and step 3 modules, as I said, are a little bit different. So if we look at calculus, we've got 4 PDFs. One is the question, one is the topic notes, hints, and solutions. Now, if you've got students who might be going for interview this Christmas, or possibly after this Christmas, or possibly next year, then curve sketching is the module that I would really, really recommend that they look at. So quite often maths interviews like to use curve sketching because it's a question where people have to put their maths knowledge together and then produce something new. So in curve sketching, there are some questions, there are some notes. So with curve sketching, there's a lot of these are the things that you should be thinking about. So it's more, these are the steps that you go through. I think there's also some discussion about turning points and concave and convex functions. Then there's hints, and then there's solutions at the end. Other things to talk about, there are some other additional supports down the side. So there is the Advanced Problems in Mathematics book. This was written by Stephen Siklos, who used to be chief examiner for STEP up until 2019, when he very sadly died. But this is available as a free download. It's got lots of the older STEP questions in it, but it's also got discussions, and sometimes there's little stories about them. So there's a STEP question about a chocolate orange, and Stephen wrote to the makers of chocolate oranges and was hoping he was going to get some, but he never did. So a bit of a background to some of the questions as well. So I'd really recommend having a look at that. The other things to look at, so work step papers are here. At the moment, we have 2019 and 2020. 2021 will go up probably about May next year. I'm over halfway on those, but we don't put them up until close to the exams. And those are very big. So this might take a while to load. We've got about 40 pages of LaTeX here. Oh, 50 pages of LaTeX. So for each one, there's the question. I've copied and pasted the examiner's report in because I find that students don't tend to go and look at examiner's reports unless they're there for them. And then there is quite a long solution. For some reason, for this one, there's marks allocated. I don't think I've done that with the later ones. So that there are things which tell you, how you might approach it, what you should be thinking about, and there's blue comments which are separate to the rest of the solution. The other thing to mention is that we've got a tab which says help. So I've tried to collect all the various facts from Cambridge Assessment Admissions Testing about actually the process of sitting the exam, from the Cambridge Maths faculty, and some other places. So if you're looking for a question about STEP, that's probably the first place to look at. So I've got lots of links to various sources of information. And at the moment, there isn't a lot in this section. We're hoping to put things like the webinar videos up here. But there is, in response to a question that I was asked, there is a list of all the foundation assignments and what topics they cover. So if you're looking at your A-level teaching and you are covering something in particular, you might want to just see whether or not there's a foundation assignment which uses the same ideas. So later down, we do introduce things like, quite a long way down, we do introduce things like small angle trig approximations, deriving the product rule and the chain rule. So you might want to have a look at some of those as well. There are links to all of the foundation assignments, so you can go straight to them from this document. And if there is anything that anyone would like to suggest in order to improve this, do please let me know and I'll get that in. Okay. So I think that's everything I wanted to say on the website. I'm going to talk very, very briefly about sitting the exam because I don't want to go into a lot of detail about this. But for those who aren't aware, there's no formula book for STEP. There is at the back of the specifications, there's a list of the formulae that we expect that they should know. What will also happen sometimes is that there might be a formula given in the question. So if there's a question where we feel that actually getting them to derive a standard integral during the question is going to take them too long, we might give them one of the standard integrals and saying, you may use this result. Sometimes also you get things like, you do not need to worry about issues of convergence in this question. That's to stop those students who are very, very, very keen on trying to prove that something actually converges and look at the tail and spend lots of time doing that. So there are quite often hints and support in the question. Crossed out work isn't marked. This is very similar to A-level, but the difference is that crossed out work that isn't replaced is still not marked. So I believe that with A-level, the rule still is that if there is an attempt made at the question, which is crossed out but not replaced, it gets marked. With STEP, the rule is if it's crossed out, it doesn't get marked. So one of the things to tell your students is don't cross out an attempt at a question until you've replaced it. So it doesn't matter if they attempt more than 6 questions, that's absolutely fine. But if they attempt more than 6 questions and they cross out one, that extra one just does not get considered. There are 12 questions in each STEP paper. 8 of them are pure, 2 of them are mechanics, 2 of them are stats. Each question, each paper is 3 hours long. Each question is marked out of 20. And the best 6 scores make up the final score. So students, if they want to, can attempt all 12 questions. That is generally speaking a very bad idea. What happens more often is that students will have quite a full attempt at, say, 4 questions, and then we'll have 3 or 4 bits. And then what will happen is that the 6 questions that scored the highest will go on to make their final score. To say a little bit more about scores, if a student's looking to do maths at Cambridge, they're looking at a grade 1, or the offer will generally be a grade 1 in step 2 and step 3. There are lots of students who get accepted to Cambridge who haven't made those grades. I think for Imperial, they say a grade 2. You can look up the grade boundaries on the Cambridge Assessment Admissions Testing website, but generally they're about 15 to 20 marks lower than these. So what you can see from this is, if we look at 2021, for both step 2 and step 3, the mark was 67. That equates to doing really quite well at 4 questions, or doing just over half on 6 questions. So that's about what you're looking at to get a grade 1. In some very old STEP advice, which I have tried to be replacing everywhere, but the myth is still out there, 4 questions are enough for grade 1. Now, strictly speaking, that is generally true, but if you look at 2017, you'd have to have 4 questions answered perfectly to get your grade 1. So my advice to students is always make sure that you have attempted 6 questions. So it might be that for 2 of them, you've only done the first bit, but just make sure you get a few extra marks on those extra questions. And hopefully that will help push you up over the boundary. Very, very quickly, if you've got students who are thinking about applying to Cambridge, this is quite an old slide, but January year 12, I'd probably say at the latest, starting to work through the foundation modules. If it's somebody who thinks they want to apply to Cambridge, you can probably start even earlier than that. So work through the foundation modules. October year 13, start to look at the step 2 modules, especially curve sketching, ready for interview. Maybe calculus module as well, that's quite a good one. So some students don't tend to do a lot of step preparation until after they've got their offer. That's probably a bit late. The earlier you can start, the better. And then there's year 13, maybe start to look at step 3 modules and then start to look at time papers. But this is just a guide. So quite often students say that actually the step support foundation modules gave them lots of confidence, and they went straight from that to time papers, which is absolutely fine. So everything we have is for students to use if they want to, if they want the support. If they get to the point where they're confident enough to start working on time papers without anything else, then just let them go. They don't have to work through the whole course. Just very, very quickly, there are other entrance tests. I've mentioned 2 of these, a couple of these briefly. There's the Oxford MAT, which is also used by Imperial Warwick and Durham and lots of others. So there's quite a lot of universities that will give a reduced offer if you get a good MAT score. But you can only sit MAT if you're applying to Warwick or Imperial. Sorry, not Warwick, Oxford or Imperial. Let's get my universities correct. MAT is written by Oxford, so it's written by people in Oxford. It is administered by the Cambridge Assessment Admissions Testing Service. So they do the sort of deal with the applications and sending out papers, but it's all written and marked by Oxford. There's the TMUA, which is the Test of Mathematics for Undergraduate Admissions. There are quite a lot of universities that will accept this. So Warwick will accept a good grade in the TMUA instead of having to do STEP. The other advantage about TMUA is that you don't have to tell universities your result. So you can try the TMUA, and if you don't do very well in it, you don't have to tell anybody. The other big advantage of the TMUA is you can get your entrance fee back for it if you are in the UK and you meet certain criteria. So there is a widening participation aspect to the TMUA. There's lots of other entrance tests. You might want to look at them because some of these have actually really nice GCSE type questions in there. So there's the physics admissions test, the BMAT. Those are very GCSE type maths questions in there. There's the ENGA, which is engineering, the NASA, which is natural sciences, the economics one, and I can't even remember what PBS is. I think it's psychological, biological, and something else. But there's lots of different sources where you can get some of these slightly different maths questions. And all of these you can find via Cambridge Assessment Admissions Testing. One last slide, and then I'll stop and see if there's any questions. So you could look at things like the TMUA and the NSAA and the MAT. Those are the 3 I'd probably concentrate on for prep in year 12. So the advantage of these ones is that they only rely on AS level single maths. So there's no further maths content. There's none of the higher A level content. So students should be able to have a go at them and know that they have the maths that they should be able to do them, but they might mean that they need to think about them. The more questions they can do, the better, but that's questions as in actually have a good go at. So the more experience you get with STEP, the more you try it, you look at solutions, you work out how all the solutions apply to the questions. You do get a lot of practice in thinking in a step-like manner. It's hard going to begin with, which is why we've created the STEP support program. So hopefully the first assignments will get students into this frame of mind in a gentle manner and help increase their confidence. And once you've done some STEP questions, you're less likely to look at a STEP question and think, I can't do it. You're more likely to look at it and think, okay, I'm not sure what to do. I'm going to try this and see what happens. Because if you've had some of those successes, it makes it much easier to look at new questions. We've designed the STEP support program. We think it is a good way of learning to do STEP. So that's what we would advise students to do. If they can start earlier, it is better. It's never too late to start, but you might have to perhaps not go out quite so often if you start very late. Use the hints and solutions, and that really is use them. It's not read the solutions, and use those to help you through the question. Try some time papers, because doing a paper where you have to choose questions is very different to papers they've had before. And finally, ask for help. So there is help out there. You can ask on things like students can ask on things like the student room. It is relatively supportive. They just need to take some of the advice with a slight pinch of salt. They can email the STEP support program. They can have a look on the websites to see if their question is answered elsewhere. They can ask teachers, not necessarily how to do the question, but where they might find some extra support on this sort of question. Okay, there's 4 websites there at the end. These are all linked to on the STEP support program website. The first one is obviously us. The second one is where you can find all the details of actually how to go about sitting STEP. So the entrances, how to register for STEP and things like this. This one here, oops. This one here is worked solutions to all of the STEP questions from the last 20 years. So sometimes they're a little bit hard to read in places because they're all handwritten. Sometimes they're not how I would do the question, but it's another source of support for students. If they can't do a question, they can have a look at one of these and try and work out how that person worked out how to do the questions. And the last one is something called the STEP database. So there is a link somewhere. If I go back to home, at the bottom, there's a link to the STEP question database, which is a really useful collection of all the STEP questions from the specimens in 1986 up to 2018. And if you want to search for a STEP question on curve sketching, you can search for a question on curve sketching. If you want to search for a STEP question on penguins, you can search for a STEP question on penguins, and you'll find the one on penguins. What is also quite useful is there is a C1 tag on this. Now, what this was supposed to do was to find questions which only needed C1 knowledge in order to answer. Some of them have been tagged slightly incorrectly, but if you're trying to find the more straightforward questions, the C1 tag is really, really useful.